How many of you are going to the party tonight versus just going home? Everyone going to the party? All right. Who's going home? I'm going home. No. All right, so get started. My name is Michael Washam. I'm a principal cloud architect at Aditi. Just about a week and a half ago, I was a program manager with Microsoft, so I was actually the PM for the PowerShell Cmdlets. So I got tired of working with those guys, but no, just kidding. So what I'm going to talk about today is just kind of a deep dive from a getting started all the way to how you actually can use PowerShell Cmdlets to do some more advanced scenarios. How many of you have used PowerShell Cmdlets for Windows Azure before? All right, cool. So we do start at the beginning, but we go kind of deep. It's just not that big of a subject, so we can kind of have a lot of coverage in these sessions. So I always like to kick off the session just with a quick overview of what can you do with the Windows Azure PowerShell Cmdlets. So obviously, automation. So the goal of PowerShell is to be able to automate, script, and do all kinds of things that normally take you a long time, that you can do them once and make it very repetitive. So from PowerShell, you can query, manage, and configure Windows Azure VMs. You can do our PaaS cloud services, Windows Azure websites, manage storage, queues, databases, et cetera, et cetera, et cetera. I think Service Bus is even in there now. I need to update my slides. And the key is you can manage all these different resources in Windows Azure across multiple subscriptions and multiple data centers. You can provision fully composed virtual machines. So if you're getting started with Windows Azure today and you go to create a virtual machine and then you realize that you have to go back to the portal to go create an endpoint, then you have to go back to the portal to create a data disk, and then you realize that you need to do that for another 5 machines. It's a really long, repetitive process. PowerShell allows you to create a virtual machine with your endpoints, your disks, network configuration all at once. So it makes it nice and fast to deploy your VMs. Second thing is if you're deploying anything in AD, you can actually have your virtual machines booted up and join the domain. So you don't have to wait for them to log in and then manually do a domain join. We just enabled remote PowerShell a few weeks ago. So whenever a VM is booted up via PowerShell or the portal, by default, remote PowerShell is turned on. So this gives you the capability of once a VM is actually up and running in the cloud, you can log into it remotely from your client, manage it, check disk, check perf mod counters, install software, whatever you want to do with this, all from your remote client. And another feature we've added is in the networking stack is we've added this was just literally a few days ago, this came out in the Source Management API, is the ability to lock down public endpoints via access control list. So I can open up SSH or RDP, which is what you get today with Windows or Linux, and then I can set an access control list on it so only a certain IP or a set of IP addresses can actually get to it. Finally, you can manage storage, so managing your virtual hard disks, uploading them from on-prem or downloading them to on-prem, and copying them between data centers. You can do all of that with PowerShell. So I'm going to talk a little bit about getting started. So my big complaint, even though I was a PM for these guys, is they are relatively hard to get up and running just because there's so much Windows Azure subscription complication involved. So I'm going to kind of give you the crash course on how to get these cmdlets configured. So the first thing you need to do is go download the cmdlets themselves. So windowsazure.com, there's going to be a downloads link, click downloads, command line tools, and PowerShell. Once you install them, there's kind of a trick here too. I'm skipping something on my slide. You first have to import the Azure module. If you install the PowerShell cmdlets and you immediately run import module Azure, it won't work because they do something part of the setup that registers Azure as a known module, and it only happens after you reboot once. So you either reboot or you have to type in the full path to the module, and I'll show you how to do that. Anyways, once you get the module imported, you need to run another command, and you only have to do this one time for your subscription. Get Azure published settings file is really powerful. What it does is it pops up IE and takes you to a website. So it really doesn't do a whole lot. But it does take you to the URL that you won't know about otherwise. You go to this website, download your published settings file. This has your subscription ID and your management cert. It actually generates a management certificate for you that you can then download to your machine. And from there, you use another command, import Azure published settings file, and this command actually configures PowerShell to use your subscription. So the first 3 cmdlets, or the first 2, that get Azure published settings files and import, you only have to do that once. We actually persist everything in your user profile, so the next time you launch a PowerShell session, they're already there, so you don't have to do that every time. The next thing you need to do is you'll need to if you have multiple subscriptions especially, you'll need to configure your subscription to use the right storage account. So in Windows Azure, I can store VHDs in pretty much any data center I want. I can put it on the East Coast, the West Coast, I can put it in Asia, I can put it in Europe, I can put it in Australia soon. All kinds of power for specifying storage, and the PowerShell commandlets need to know which continent you want to put your VHDs on, is really all it's asking here. And finally, since we are multi-subscription aware, you have to tell it to be a select subscription if you have more than one, to tell it which subscription you want to work on. And then once you do all that magic, you can call a Azure commandlet. Oops. So let's walk through, show you how that works. So if I was just getting started, the first thing I had to do is go to windowsazure.com, hit Downloads, Command Line Tools, and Windows Azure PowerShell. And this is going to launch the WebPI installer and let it put everything it needs to on my machine. And luckily, I've already done that. So it's just going to spin for a second and say it's already installed. Now, one thing to know, the PowerShell commandlets are actually updated about every 3 to 4 weeks. So if you're an avid PowerShell user, go check that download link often, because usually there's new functionality literally every 3 weeks. The ship cycle I was on before I left was every 3 weeks. I think they were extending that out a little bit because it was pretty hectic. But these rev very fast, so anytime we add new functionality, it's going to show up there first. So once the PowerShell commandlets are installed, I'm a big fan of PowerShell ISE, but feel free to pick whatever your favorite PowerShell editor choice is. And this is a path you'll memorize eventually. You memorize that, or you install, reboot, and just type in import module Azure. Take your pick. So this is the one that'll work without rebooting. You do that, everything is set. So now that you've got the PowerShell module loaded up, all these these Azure commandlets will show up in your dropdown. So basically how we did the naming prefix is verb name, our noun prefix is Azure, and then whatever resource we happen to be working on. So the one that we're wanting to look at for getting started, of course, is get Azure publish settings file. Hit that, and it's going to automate IE for me and take me to this random URL that you don't have to remember. And the first thing it's going to do is pop up this download file. I'm already logged in with my Windows Live ID, otherwise it would ask me to log in. So I can take this really long file and put it in a directory. I'll put it in this directory. And the final step I have to do to actually get my subscription configured is import that file I just downloaded. It's kind of long. Now this is actually installing this in a XML file on my local machine, so I don't need this file ever again. I can actually delete it if I want to, unless you want to copy it to another machine and import it there. So now I can call get Azure subscription, and it'll dump out a ton of information. So this is all the subscription settings that my account has admin rights on. So I have a DD demos, cloud practice sales demos, until I do a lot of demos. So that's kind of the gist of it. But now let's get back to the point about selecting your storage location for whenever you start creating virtual machines or cloud services or whatever. So how to do that is you first need to know your location. So get Azure location. This commandlet will basically enumerate all the data centers that you have in your subscription. So I can scroll down and I can see North Europe, North Central US, East Asia, et cetera, et cetera. And one thing to note is not all data centers are equipped for virtual machines. So if I look at North Central or South Central, they only say the available services are compute and storage, where the one right above it talks about compute, storage, persistent VM role, and high memory. So the high memories are the new virtual machine SKUs that were just announced a few weeks ago. So if I was a brand new user, I would pick one of these locations, say East US, and I would create a new storage account. Just give it some name. It does have to be unique, so make it random. And this will actually create the storage account that you'll use to create your virtual machines. So while that's waiting, I actually already have a storage account waiting. It's already created. And I'll show you the configuration of the subscription I'm going to use. So if I do this, you can see down at the bottom, my current storage account is set to SMIS-demo1. It's just some random storage account name. But as long as you have a current storage account set, that's how you know where your VHDs are going to be stored. So that's pretty much all it takes to get set up on your subscription. Now, again, when I call select Azure subscription, that's going to put the context right, so anything I create is going to execute in that context. So now let's talk about actually creating something. So say I wanted to create a virtual machine. First thing I need to know to create a virtual machine is the image name. So to do that, I'm going to call another commandlet, and I'm going to filter out just so I can see the image name. Otherwise, it returns back a ton of data. So get Azure VM image will return back all of the images that you can see in the portal, and then actually there are quite a few of them that you don't see in the portal as well. So you won't see any of the right image virtual machines images, and I think that's actually the only ones you won't see are the right skill ones. But in the future, there'll probably be other vendors and stuff that'll put them out there that's not designed for actually showing up in the portal. So for creating a virtual machine from PowerShell, I'm going to go ahead and select the VM image name I want, and save that guy. Now I don't need this code anymore. And to create a new Azure virtual machine for PowerShell, you need to call the new Azure VM config commandlet. Because how the PowerShell commandlets work is we actually create a virtual machine configuration, then we use other commandlets to modify that config. And once everything's set on the config, we actually use that config to post up to the Windows Azure Service Management API to actually do whatever we want to do, whether that's a create or delete, or create or an update, I mean. So whenever I create this object, I'll say my VM1, specify the image name and instance size. I'm actually not creating a VM. I'm just creating an object. Let me show you what that looks like. So if I dump that object out, you can see that it's really just creating an object. See the availability set name, configuration sets, data hard disks, etc. Now what I want to do is I want to modify that object to have everything I want. So if I wanted to have this virtual machine boot up with a data disk, I can say create new, say 500, and label. So now when I update this object, actually you can't see it unless I dump that out. You can see that I have a data disk attached to this object as well. And you can do the same thing. You can attach multiple data disks here, or you can open up network endpoints. So I'll open up an endpoint on this guy. Okay, so now we've created a VM configuration that's a Windows Server 2012, instance size small, and we'll have a 500 gig data disk and port 80 open on the web server. Now, if I wanted to add multiple endpoints, I can easily copy and paste that. You know, if I have a service that's going to run on port 8080, and now I have an object that can do both. So the beauty of PowerShell is once I figure out exactly what I want, if I wanted to create two of them, I can literally copy and paste that code, change a couple of parameters, and now I have two configurations for two VMs. So now the code to actually create the virtual machines is using the new Azure VM commandlet. Here I need to pick the database or the data center location, so I'll pick West US. And then I need to pass my configurations. Oops. And I did forget a crucial piece of this, which is a provisioning config. We need to tell the Service Management API whether you want to create a Windows machine or a Linux machine, and also what the username is and the password. So this is where copy and paste gets tricky. Whenever you screw up the source and then you copy it, you got it screwed up twice. So now we're going to go ahead and create 2 virtual machines, both with 2 network endpoints each and 2 500 gig data disks. So even accounting for explaining it and typoing it, it's still faster than going through and setting this all up in a portal. So let's jump back over to our slides a little bit and talk about how you update it. We just saw how you can use a few lines of code to create a couple of virtual machines, but how do you actually go off and modify something that's up and running? So again, working out this concept of a configuration, right? We're really just working with a big blob of XML. If you really want to know the truth of what we're passing back and forth via PowerShell, it's just a big blob of XML. So when I call get Azure VM, it's returning back a big blob of XML. I then use other commandlets, just like I did during creation, to modify that XML, and then I pass it back to the API via update Azure VM. So this is a pretty concise pipeline version of how you do an update. Get Azure VM will return the VM configuration. Add Azure Data Disk modifies it by adding a new disk, and Add Azure Endpoint modifies it by adding a new endpoint, and then Update actually posts it. Now, if you want to, I've been told that this format looks more readable, so I return the VM config. I then add Azure Data Disk, and I pass the config as a parameter. Add Azure Data Endpoint modified, and then Update. Either way, I hope that kind of makes the concept a little clearer. So let me switch back over, and we'll update a virtual machine too. So you can see the first 2 virtual machines are still in the creation phase. So I'm going to open up another tab here. And I'm going to show you a real quick commandlet that comes in very handy. So get Azure VM has a couple of use cases. If I call it with no parameters whatsoever, it actually just returns back the service name and the VM name and the current status of the virtual machine. So, and it can be a little slow because basically for every cloud service you have is a separate API call. It's going to get the cloud service and it's going to enumerate all the VMs inside that. So if you have 100 cloud services and it takes a while, that's why. So here is how we could update a VM. Let's take this virtual machine. It's just a Windows server. So I'm going to go ahead and just call get Azure VM with the service name and the name. Does everyone know why I'm specifying service name? Did you watch Mark Cercinovich talk, where he talked about cloud services and their container? So I'll point that out real quick. So anytime you're dealing with a virtual machine in Windows Azure, how you reference it is via the public DNS name and then the actual virtual machine name inside the cloud service. So if you want to know what that cloud service name is basically down here at the bottom, the DNS name, the host name, is what the actual cloud service name is. And from an architecture-wise, it actually works where the cloud service, the public DNS name, and then all your virtual machines are contained inside of it. So that makes a little bit of sense. So just think anytime you want to reference a VM from PowerShell, cloud service name, VM name, and you should be good to go. And I had a typo in mine, I think. So notice it's the same commandlet, but you get a different output. Whenever I specify an actual service name in the name, I actually get the live running configuration of that virtual machine. So you can see we get the incident status, the power state, see what fault domain it's in. You can see the public DNS name, et cetera, et cetera. So I can also pipe this out to other commandlets to get more in-depth information. So I can say get Azure Endpoint. Oops. And this will actually dump out the network configuration of that virtual machine. So as you can see, I have a port 5986 for remote PowerShell open and 3389. So now we're talking about update, though. So let's go ahead and add another endpoint. So we'll open up web. Oops. So what I'm doing is I'm taking that return configuration, I'm passing it to add Azure Endpoint. It's implicitly passed. That's why you don't see the VM parameter. It actually comes as part of the PowerShell pipeline. it modifies that configuration by adding that endpoint to it, and then I hit Update Azure VM to actually update it. And you can do the same thing with data disks or whatever you want to do. If you want to change your disk cache settings, it's the same way. And it always takes a few minutes to actually do the update. Okay, so let's talk a little bit about remote management with PowerShell. So this is brand new. This recently, I think it was literally just added a few weeks, maybe a month and a half ago. By default, it's turned on. So whenever you go through the portal, or if you create it from PowerShell, you're going to have remote PowerShell turned on. There's flag in the new Azure VM, actually in the Add Azure provisioning config commandlet to turn it off if you don't want it. And there's a checkbox in the portal to turn it off if you don't want it. It's very secure, though. We actually generate a HTTPS cert on our own. So whenever you create the VM, there's code that runs inside the ISVM on provisioning time that actually generates a self-signed certificate and installs it as a WinRM certificate. And then you can download that certificate, install it on your local machine. That way you can validate who you're talking to. Now, by default, we don't turn on HTTP. It is optional, though, so you can turn it on and have VM-to-VM communication within the cloud, but we don't turn it on by default. So that's something you might, if you want to launch a script on a VM and then have it remote into other VMs on your inside your cloud service, you'd want to turn on HTTP just to make it simpler so you don't need to manage with certs. And this is really useful for in-guest customization, or basically customizing your virtual machine when it boots up, or monitoring. You could have a script that enumerates all your virtual machines out in the cloud, checks the disk space, checks perf counters, whatever you wanted to do. You could completely automate your management that way. So some of the more detailed parameters that you get whenever you're using the PowerShell commandlets, we have a dash wait for boot flag. This comes in really handy whenever you want to provision, just like we saw, create 2 virtual machines, and then once they're booted up, do something useful with them in remote PowerShell. So what it does is it polls. At the end of creating the virtual machine, it actually goes off and polls your virtual machine to see if it's in the role ready state. And if it is, that way it knows that you can log in and do something useful with remote PowerShell. So it's not assuming that you're going to sit around and do this manually. This is really for automated processes. Setting up the connection. So one of the tricks to using remote PowerShell in the cloud is that architecture I just described earlier. You have one public DNS name, which means you have one IP address for multiple virtual machines. So how do you address each individual virtual machine behind that IP? They all certainly can't listen on port 5986, right? Because you can only have one IP on one port. So what they do is whenever we generate WinRM endpoint, the public port is randomized. So the public port is actually 50,002 or 5063, whatever. And we added a commandlet called get Azure WinRM URI that will go off and figure out which is the WinRM URI for you. So you don't have to go log in and figure it out first, because it kind of breaks automation if you have to go to the portal and figure out what port you want to use first. We have a helper function that's published. It's up on my blog. It's up in a Git repo that actually does that code that will download your WinRM cert, so you don't have to worry about that. And then from there, you can invoke a script block, use an invoke command or enter PSS session, which basically puts you into a remote PowerShell console. How many are you familiar with using remote PowerShell? A little bit. So how many of you have ever deployed SharePoint? Okay. You've ever wanted to? No. So just to give you an example of what this can be used for is we've written 2 scripts in the past couple of months. One of them I demoed earlier in an automated deployment session, which basically will, from a single config and a single script, you don't have to write any code additionally. It will deploy IS or 2 web servers or multiple web servers in number of servers, and then it'll install IS and it'll actually install web deploy, so it'll do content synchronization. So basically from a single script, you can deploy a full web farm. And that's a pretty cool demo. I mean, I think I would actually use that, and I used it for setting up my demo here. But another set of scripts that we wrote is a little bit deeper. This one will actually do a full-blown SharePoint farm deployment, and not just one big giant virtual machine with everything on it, which is pretty much useless. It will do a full interior SharePoint farm, and even at the SQL database layer, it configures SQL Server always on, where literally you go in, modify a script to tell it what subscription you want to use, and hit F5 and wait 5 hours, and it goes off and makes a farm for you. Considering if you did that manually, it'd probably take you a week and a half. It's a pretty good plus. So let's jump over, and I'll show you a little downscale version of what you can do with remote PowerShell. So let's use this server as an example. So this is a function I was just telling you about that tells you what the PowerShell URL should look like. So I'm just going to print that out to the screen. And you can see it basically gives you the full URL plus colon 60,074. And the only way you know about this is 60,074 is if you went and looked and figured out what the RDP or the WinRM endpoint is and got the public port for it. This commandlet basically saves you from doing that. So what I can do with it now is I can enter a PS session. Now, one thing before I execute this, it actually will not work until I use that helper function, which installs the WinRM cert locally. So this is just an include file I have here in a PowerShell script. Let me go ahead and open that real quick just to show you what it looks like. So this is the entire function. You don't have to memorize this. Thankfully, that's what's nice about having it posted on a blog. You just have to copy and paste it, put it in your code, and it just magically fixes everything. But what it does is it figures out that generated cert that was on that virtual machine. It downloads it from your certificate store, and it installs it in your local certificate store. So one thing to keep in mind is if you try this, you do have to start PowerShell ISE elevated because it does install stuff in your certificate store. So now I can put my service name and my VM name. You know, the one thing is you only have to do this one time per that machine, though. So if you routinely use remote PowerShell, you only have to, just keep in mind, you only have to do it once. Okay, so it'll go ahead and install that WinRM cert. Then it's going to prompt me for credentials so I can actually log into the machine via remote PowerShell. All right, so I don't know if you can see that, but down at the bottom, you can see at the prompt, it's actually at the cloud service, MWRDP client service1.cloudapp.net. So this code is actually running on that remote server up in the cloud. So that is a remote DIR. Not that impressive, I know. But. So now that you can know that you can just log in, it's pretty easy just to log into a machine remotely and do something with it. Take it to the next step and actually execute something on it. So we could do, instead of enter PS session, we could do invoke command, which takes the same parameters, that URI, the credential, and then it also takes a file path. So this is something that I could pass in a script, just some random PowerShell script that does something interesting on the server, and it'll go execute it for me. So if you're in my earlier session, sorry, I'm going to show it again. Real quick script on how to install IS on this machine. So this script, all it does is it uses server manager features and roles and feature commandlets, and it installs IS. Oops, didn't need to do that again, but that's okay. So invoke command will use the same credential prompt. And if you're wondering how do you automate that prompt, yes, you can make get credential silent. It can read password and username from a parameter. So you can see it actually executed, and it said no change needed, which I guess I think I ran this on the same machine earlier, but it did execute that script remotely. So this is really all you'd need to do to jump in and do a customization on a virtual machine that after you deployed it. Okay, so let's talk a little bit about image and disk mobility. So I know this kind of sounds buzzwordy, but really all it means is the ability to get a VHD from your local Hyper-V system, move it up to the cloud, or vice versa, take a VHD that's running up in the cloud and move it down to your local Hyper-V system. So we have two commandlets to help you with this. First one is add Azure VHD, and the second one is save Azure VHD. So this literally gives you the ability to fully script an automation of a virtual machine. So if you have a virtual machine that has 2 or 3 disks in it, you can use Add Azure VHD to upload them. And one thing really nice about using Add Azure VHD is I wouldn't call it super intelligent, but it's fairly intelligent. So it only uploads bytes that actually have data in them. So if you have 27 gig VHD and you only have 30 gig of used space, that means there's 97 gigs of just empty zeros on that disk. Add Azure VHD does not upload those 97 gigs of zeros. It's optimized to a point where it only uploads the stuff that you are going to need on the other end. The disk will still be 127 gig. It just doesn't actually upload all the stuff in between. So Add Azure VHD does the upload, and then Add Azure Disk is different. It doesn't do an upload. What it does is it takes the VHD file you uploaded and registers it so Windows Azure knows it's a disk. Because whenever you upload a VHD to storage, it doesn't know VHD from an image at that point. You have to tell it by registering some metadata around it, and that's what Azure Disk does. So a path you could use to migrate in full VM is Add Azure VHD, Add Azure Disk, and then pass the disk name to new Azure VM config instead of an image, and the VM will literally boot off that disk instead of provisioning from an image. So let's show a real quick demo on VHD mobility. Okay, so what I want to show you is how we can upload a VHD. So I have a real simple script here. Let me make that font size a little bigger. Actually. I always forget I can do that. So before I do that, I'm going to go ahead and create a VHD. So I'm going to do our administrative tools, computer manager. And I'm going to create a real simple VHD called My Data Disk. And I'm going to make it 50 meg so we don't have to sit here all day wait for it to upload. Okay, and now that it's there, I'm going to go ahead, initialize the disk, create a simple volume off of it, format it. Okay, and then we'll copy something over to it. This is the super efficient way of transferring files up to your VM. Not really, just kidding. So put my PowerPoint on the disk, and now I'm going to go ahead and detach this guy because we're going to upload it. Okay, so now I'm going to use this script to basically upload it to the storage count. So you can see the source VHD is pointing to that directory that I just saved my datadisk.vhd. And the target storage count is, this is a storage count I have on the West Coast, mwstus.blob.core.windows.net, and I'm going to put in the upload/my-data-disk directory. So I'm going to use a non-command line tool to show you what that looks like. So this is the mwstus/uploads folder. As you can see, there's nothing in it. So let's go ahead and kick off the upload. It's calculating how much stuff to use, obviously not a lot. Detected empty file blobs, and it's uploaded. So we now have VHD. The next command it's doing is the Add Azure Disk. So Add Azure Disk, this is the one actually registering it in Windows Azure so it knows that it's a disk. So it just registers it as well. So I can now call, if I wanted to, I can call get Azure Disk. Oops, not the right code. And my data disk, and it'll give you all the properties about that disk because it is registered with the service. So it's not, you can see attached to is null. I haven't attached it to a virtual machine yet. It's in the West Coast. Here's the location that you can download it from, et cetera, et cetera. So now let's go ahead and attach it to a VM. So let's do that. We saw how to do this earlier with the update. So I will reuse those parameters, and I'll put it on our RDP client. Oops. something failed there. I'll take a look and see what that was. So when I add an existing data disk to my VM, I'm going to use the import flag. This name is going to be my data disk. And I do have to tell it which LUN to put it on. So I'm going to attach it to LUN 0. And I'm going to call update Azure VM. Okay, and while that's running, let's RDP into that VM so we can see it. Okay, so this is a VM that we're uploading that data disk to. So it's not there yet. By default, we only have the Cmd drive. I don't have any data disks attached to it. But assuming the commandlet works, we should see like I think it'll be an F drive pop up shortly. Oh, there it is. So here's our F drive. And you can see the PowerPoint. So now that we're established that we're going to use VHDs to transfer basic small text files and PowerPoints around, let's go ahead and send something back. So I can't have a typo on my demo. There we go. Okay, so now we want to do something similar. We want to get rid of it. We want to take this back. So what I want to do now is I want to detach this from that VM. And you guessed it, we use that with move Azure data disk. Let's push LUN 0 and update Azure VM. So now that this is not going to be attached to that virtual machine anymore. So it's very similar to Hyper-V, except it's not a pretty GUI. You just no right-click and add disk. You have to actually type in some stuff. But it's cooler because it's in the cloud. So that should be removed here momentarily. And while we're doing that, let's set up our download code. So the code is going to be very similar to add, except the source and destination are going to be reversed. So the source is going to be the URL that we uploaded it to earlier. So MW West US 1 upload / my data disk. And the destination is going to be the same directory I uploaded from, except I appended -downloads to it, so I don't have to overwrite the existing one. Okay, and let's go ahead and download that. Oh, it's still running. Hold on. Okay, so this should download the VHD to that directory. Which got closed. Yep, there we go. Okay, so here's our freshly downloaded data disk. And you can see that we have successfully copied a 1K text file, only in like 20 minutes, so no. This is actually very useful it's really useful for moving VHDs with real data in them. And you can actually upload bootable disks too. So the only thing, whenever we showed this was at Azure Disk, that made it a data disk. There is actually a flag on there. If you want to take a look real quick. Here, I'll show you. If you wanted to upload an OS disk, you'd use the exact same command, add Azure Disk, except the difference is you'd specify the OS. It would either be Windows or Linux. And that marks it as a bootable disk. So whenever you go to create a virtual machine in the portal, or even from PowerShell, the Source Management API knows that this is a bootable VM and it's not just a random data disk. Okay, so let's jump back to our slides real quick. So this is another really powerful feature that was recently added by the Windows Azure Storage team. There's basically a service called asynchronous blob copy. And what this is really useful is getting blobs. They can be VHDs, they can be images, PDFs, whatever you want, from data center A to data center B. So if you think about the traditional pattern, if you've set up a SharePoint farm or a virtual machine on the West Coast or in someone else's subscription, and now you want to get it on the East Coast, how do you do that? If it's 150 gigs of VHD files, do you download it to your local machine first and then go to upload it? I mean, you can certainly do that. It's painful, but you can do it. So this is why the async blob copy service was created. The general idea is you call start Azure storage blob copy, and it makes a request out to the destination server that tells it to download a blob from the source server. So this source can be anywhere. It could actually be in Amazon. It could be on an FTP server, anywhere that's publicly addressable. So as long as that storage service can get to it, be it without passing authentication, then it can actually copy it. So let me show you a couple of examples of how to copy VHDs between data centers. So let's jump into this one. This one's a little bit of code, but I'll explain to you what it does. So the first thing to note is I have a source URL. This is MWS test copy 1. It's a storage count that's on the West Coast data center. And the target storage count does have to have authentication. So I'm pointing this to MWS US2. So it's another storage count in the same region, same data center location. And this is the actual storage account key that the storage service is going to use to do the writes, because the write is authenticated. The read is not, but the write is. So I'm going to create a storage context that tells the Cmdlets how to authenticate to the target storage count. And from there, I'm actually creating a container, which is just, if you're new to Windows Azure Storage, think of it as a directory, called copied VHDs. And there, I'm going to call start Azure storage blob copy. And this commandlet takes the blob that I copied and checks the status of its progress. The beauty of this design is I can call start Azure storage blob copy, on numerous VHDs at the same time, and they're all going to kick off synchronously. It's not going to wait on it to finish before it starts the next one. So this is how you can use the Windows Azure Storage Service to copy a lot of data quickly between data centers. So let me show you these two data storage counts in Cloud Explorer. So here's my test copy 1. This is a 133 gig VHD. I don't have zoom in on here for some reason. Here, let me fix that. I'm really annoyed that I can't zoom. I hope I don't make everyone sick from zooming too much now. Okay, so test copy 1.vhd, 133 gigs. It's a pretty big disk. So I'm going to copy this from storage count A to storage count B, or realistically, this storage count to this storage count, both on the West Coast. So I'll go ahead and hit F5, and it should print out the status, and it's done, which is awesome. How many can you copy 133 gigs instantly in the cloud? That's just cool. Now, that doesn't always work, and let me tell you why. Within Windows Azure Storage, if you have two storage counts in the West Coast, and you think, hey, I'm going to go do this. It only took Michael, a fraction of a second. It was awesome. Saved me a lot of time. And then you go start your copy, and it takes 45 minutes. You're like, what the hell? What happened is inside of that region, there's multiple storage stamps. So there's a whole separate container of where your storage actually goes. And you don't have control over which storage stamp your stuff goes into. So it just so happens that those two storage counts I created are all in the same stamp. And how you know they're in the same stamp is because the storage count IP address will always be the same. So MWS2S1 and MWS2S2 is actually the same IP address. Different storage counts, but same IP. If I create another storage count that happens to be in West US region, but it has a different IP address, it's going to be in a different stamp, and it's not going to be a shadow copy, which is what we just showed. It'll be a little bit longer. It's still going to be remarkably fast because we're copying it over high-speed links, but it's certainly not going to be, by the time I can scroll up to show you the status. So I'm going to show you a longer version, which is probably more what you'll use this tool for. And this is copying one across regions. So this one is going to copy the same 127 gig disk from West US to East US, so all the way across the country. So let's go ahead and kick that off. And as you can see, it's not successful. It's not done. That would be really cool, though, wouldn't it? I mean, you got to admit. But it's not, so it's only marginally cool. So what we can do, though, is the blob returned from the start Azure storage blob copy, we can actually call it pass it back over and over and get the status of it until the copy is done. So you can see we've already started copying bytes. So every time you run this, you'll get an updated version of it until the copy has been completed. And of course, you can, I've used this all the time to copy multiple VHDs between data centers or subscriptions even. Note, there is no subscription context here. It's just storage key context. So a lot of the use cases you'll see for this is, if you created a subscription, a virtual machine over here, and you really want to move it to a different group, you can use these commandlets to move these disks around. Okay. So moving forward, access control lists. This is a brand new feature that just literally came out last Wednesday, I think. The portal doesn't support it yet. It's only available in PowerShell. But what it's really useful for is basically restricting access. So say you created a virtual machine, MySQL Server 1.cloudup.net, and you open up port 1433, so say a Windows Azure website or a service from running in Amazon or whatever can access it, right? Because you're not always going to have everything on the same virtual network. Sometimes you're going to have to expose these public endpoints. So what you can do to lock this down, because I've actually had a customer say, hey, I did this architecture and getting all these errors in the event log from people typing in bad passwords. Am I getting hacked? You're getting attempted hack. So you're not hacked yet. Because you need this. This will keep those people from even attempting. They can't brute force. They can't do anything. You add an endpoint ACL. Basically allows you to set up to 50 rules, permit or deny, or allow or deny for your permit rules, and you give it a remote subnet. You can give it a description and an order of the rules processing. So what this allows you to do is allow your friendly website to have access, but everyone else not so lucky. The code to do this is not overly complex. It's a little complex for updating existing ones. It's real simple for creating new endpoints. So the general idea is we create a new Azure ACL config. This is the access control list object. And then we have a second commandlet called set Azure ACL config that allows you to modify it, to basically add or remove rules from that ACL. And then you modify the actual endpoints on the virtual machine via set Azure endpoint. So this real simple script will basically lock down an endpoint for SSH. Let's walk through, show you how that works real quick. Oh, wrong button. There we go. I don't think I ever hit enter here. There we go. Still copying. So on ACL, so this is the exact same code I just showed you in the PowerPoint slide. I think the IP address might be different. Let me see what my IP address is real quick. I'm going to use Google, sorry. They have a nice functionality when I type in what is my IP, it actually tells me. It comes in real handy. So I can take the IP address of whatever proxy server I'm currently going out from and put this in the script. And it takes a CIDR notation. So I don't know if this proxy is going to come from multiple IP addresses. It actually could be a class B, and this might break eventually too. But I'm going to take my chances and do a class C, which is hopefully I'm not coming from more than one of these IP addresses. But before I do this, I'm going to verify that I actually can connect to this machine. So I have a Linux server out here. Oops. That I'm going to try to SSH into. I have a SSH endpoint open on it. So as you can see, I have network access to this endpoint. I can log in, and don't know my password, of course, but that's not a networking problem. That's a user problem. So I can SSH into this machine, and I'm going to go to another machine out in the cloud that has not on the same proxy here to verify I can get in there as well. So this is a VM running actually in Windows Azure. You can see I can log in here as well. So let's go ahead and apply this ACL. So theoretically, whenever this update is complete, the only one that should be able to access this Linux server is everyone that's following this proxy server. The last time I ran it, it took about 3 to 5 minutes to update. So let's come back and test this one here in just a few minutes. So see if we can get through a little bit more content. Okay, so let's talk about designing for scale and availability. So question. Question is, can you do ACLs for PaaS, web and work role? And the answer is unfortunately not yet. It's in the works, but this access control is only applied to IS virtual machines at the moment. Were you asking the same thing? Yeah. Sorry. I was actually the PM for cloud services before I came over, and I was actually requesting this very strongly as well. Like, what's up with that? How many of you are familiar with availability sets? Okay, so what an availability set does is it basically allows you to take a group of virtual machines. Say you have 2 web servers or 2 SQL servers or n number of servers that do the exact same thing, and it splits them up across multiple data centers racks in the data center. So what this gives you is, if you have 4 web servers, could potentially split it up, maybe 2 to 3 racks. What it gives you is redundant power supply. It gives you redundant switch and load balancing. So if we lose an entire rack in the data center, any of those single point of failures fail, half of your application is still up and running, or maybe more, depending on how many virtual machines are in that availability set. The other thing it does is it tells the Windows Azure Fabric controller how your application is structured, so whenever it has to do updates at the host or the actual host, which means it's going to reboot your machines, it doesn't reboot all your web servers at once. So, Windows Azure, the Hyper-V is running Windows Server 2012 Hyper-V. Just like Windows Server 2012, it has to be patched, has to be updated, and whenever it's patched and updated, occasionally it does require a reboot. And whenever that happens, they're going to take down the virtual machines that are running on that host. So how you avoid downtime and get that 99.95% SLA is grouping machines that do similar tasks, like domain controllers or web servers or SQL servers, into an availability set. It's really simple. It's just a property set at VM creation time. And what this does is whenever a host update rolls through, the Fabric controller will only bounce servers, or it won't bounce all your servers in that availability set at once, because it knows that how your application is structured. Second thing I want to talk about that increases your high availability is load balanced endpoint sets. Everyone knows what a load balancer is and why they're valuable. It distributes load, but it can also be used for high availability. One of the things that you can do in Windows Azure is define health probes. So if you have a web application that, say you have 2 or 3 web servers, if you have a web application and something bad happens on one of those virtual machines, say it doesn't go down, say it just is starting to return a 500 error, a misconfiguration on one of the VMs, you certainly don't want that virtual machine in the load balancer. You can actually tell Windows Azure to point to a specific URL to detect the health of your application, and if it returns anything other than a, hey, I'm good, 200 error, then it's going to yank it out of the load balancer. So how you can design a highly available solution is basically having availability sets at each tier. So you definitely don't want availability sets to span tiers. You want them to encapsulate a tier. So you define availability sets for your web front end, your data back end, and then you're going to end up having load balancer at the public front facing. We don't have internal load balancing yet, so it's only a public load balancer that you have to worry about at the moment. So how the custom probes work is a little bit more detail. Well, there's 2 types of probes. There's a TCP probe, and then there's an HTTP probe. The TCP probes are really useful. They're kind of the dumb probes. What they'll do is they poll every 15 seconds, and instead of actually looking for an HTTP request, they're not that smart. They just basically do a socket connect, and if they get an acknowledgement back, then that machine is good to the TCP load balancer probe. If it doesn't get an ACK, then it's going to stop traffic on that port, and it's going to take the node out. So the good news is it does continue polling. So if you went to the machine and you were doing some kind of maintenance on it, you just shut down IS or whatever service you're working on, do whatever maintenance you want, turn it back on, it's going to automatically be added back to the load balancer. There's nothing else you have to do. Now, what this doesn't do is it doesn't detect 500 errors. It's just detecting a socket connect. So if your website is crashing, you accidentally applied something goofy in your config files, and you didn't realize it, it's going to be seen out to your users. It's not going to stop that. So that is where the HTTP load balancer custom probes come in at. They're a little bit smarter. And so instead of just looking at a specific port, they're actually looking for a specific URL. So you can pass it, /healthcheck.spx, or you can put it at the root of your site, if it's anonymous, which does lead me to point something out. This does not work on an anonymous URL. So the first thing you'll notice if you ever try to deploy SharePoint or something that requires AD authentication, for instance, and use probes, is it's not going to show up in load balancer because the load balancer doesn't have any credentials to hit your site with. It's just going in completely blind, completely anonymous, and it's going to get back a 401, which to the load balancer says your site's not up. Sorry. So what you do in that case is what I've told people to do with SharePoint, or for instance, is create a virtual directory in IS or whatever you're monitoring and enable that for anonymous, and you can specify the anonymous path whenever you create the probe. So again, the walkthrough is it pulls every 15 seconds. This time it actually cracks open the response from HTTP. If it gets anything other than a 200 error, then it's going to stop traffic, but it does continue polling. So let's walk through a real quick demo of configuring the load balancer. But before we do, let's check and see if our ACL is happy. So the update did work. So I should be able to go into, actually shut this one off. Get that URL back, and let me try to connect via PuTTY again. So I can still log in here. Slowly, but I can. Here we go. All right, now can I log in from my Windows Azure client? And life is good. I've locked it down to only the TechEd conference, so minimal number of people that know my password, that can hack me. Only 6,000, or I don't know how many people's here. A lot. So definitely, that's going forward. You should absolutely use ACLs to lock down your public endpoints. Okay, so let's take a look at configuring the load balancer. So to do that, I'm going to show you the code on how to create a load balanced endpoint, but I already have one, so I'm just going to show you what it would look like if you were doing this yourself. Oops. So again, we're going to create a new Azure VM config. We're going to have a provisioning config. We're going to deploy Windows. It's going to be mwasham in my unhackable password. And now if I wanted to make a load balanced endpoint, I would add Azure endpoint, name, web, protocol, TCP, local port 80, public port 80. Oops, not directional return. Probe port. This is the probe port I was just telling you about. Because one thing to keep in mind if you do enable probing is it doesn't have to be on the same port as your web application. You can have your web app on port 80, and you could actually have an anonymous health endpoint listening on 8080 or whatever you want it to do. So those don't have to be the same. Probe protocol HTTP or TCP. This is how you flip the option I was just showing you in the slides. And the probe path. And there's a couple other things. You notice the 15 seconds I was mentioning. Those are actually configurable. You can configure them to be longer or shorter, but I don't think it gets a lot shorter than 15. So this could just be to the root of your site, or it could be to healthcheck.aspx. Whatever you feel like doing. And then this would be new Azure VM. And now whenever this VM is booted up, it's going to have a load balanced endpoint. The magic is whenever you create other VMs that have the exact same load balance endpoint. If they have, oops, wouldn't have worked. If they have this setting, LB web, and it matches, whenever they all boot up, they're all going to be load balanced on the same port. Now, just to show you that, I have a set of load balanced VMs up and running. Get the cloud service name. And I'm going to pipe those two VMs out to get Azure endpoint so I can dump out the endpoint configuration. So you can see I have 5986. I have 8080 open because I have web deploy configured on this, and I do web deploy publishing over 8080. And here is the load balanced endpoint probe, LB web, and it's going to /home/health check. I have a MVC page that listens on that request, and it can optionally return 200 or 500 to test this out. And then the other endpoint for the other virtual machine is up here as well. Okay, so let's test this theory out. So the first thing I want to show you is browse to this site. And you can see that currently being served from ISWFE 0. You can see that right there. Now if I hit F5 a couple of times, there we go. Now we're served from ISWFE 1. So we're getting load balanced. Okay, so what I want to do is I want to modify my checker. So I have a little bit of code here in the health check controller method that basically says if the current VM is in my configuration, return 200. If it's not, throw a 500 so the load balancer will take me out. So my web config, I have a little code here, active servers, and both of those VM names. So if I take out ISWFE-1, it'll take it out of the load balancer. So before we get started on do that real quick, actually, let me go ahead and do that. So I'll go ahead and take out ISWFE-1, hit publish. It's going to copy out to web deploy, and web deploy does a scheduled task that copies in between all the other VMs. So as you can see, it landed on ISWFE-1, right? Obviously, it's not that fast. It's going to take 15 seconds for the load balancer to come back and check, get the 500 error, and then it's going to take it a few seconds to kick it out. Plus, I also have a minute of content synchronization delay. So this demo takes it anywhere from a minute to 2. So let's go ahead and log into that VM real quick and take a look at what it's doing. Okay, so here are the log files for this website. You can see the only thing that's really been hitting it is I got a bunch of 404s earlier from whenever I deployed and I turned this on and I didn't have my website set up. But then once I had the website turned on, where it was working, I'm getting a bunch of 200s. So you can see the 200 errors, which means everyone's good, and that's whenever it was in the load balancer. Then if I scroll way down, I don't know if it's hit 500 yet, but not yet. So here in a moment, I should see a 500 error at the end of that log. There we go. So now the load balancer is getting 500 errors. So instead of being a happy 200 or whatever, I'm throwing a, hey, I crashed, I don't know what's going on error. So now when I go back to the load balancer, in theory, I should only ever see ISWFE 0 again, at least until I go fix my load balance endpoint. So this can be really useful for actually writing some code to detect that you can do transactions or your database is happy. It doesn't have to just be that IS is up and running. You can add some serious logic to this to make sure that your application is up and running. Okay, so heard a couple of people that do web and work roles. How many are doing cloud services paths? Oh, cool. Good number. Usually beats the number that I see when I talk about IS. So from a cloud services perspective, we've done quite a few things recently. I know most of the work in PowerShell has been around IS, but we've actually started going back and adding some functionality to PaaS as well. So just the core stuff that you can do from cloud services, you can deploy CS package and config files. You can deploy PaaS services to Windows Azure Virtual Networks. So if you go to Visual Studio, you can't deploy to a VNet. They didn't know that either until a few weeks ago, which is shocking. But and the reason is because when you deploy to a VNet, you always have to deploy to an affinity group. And with a cloud service in an affinity group, and the only thing you can do from Visual Studio is a data center location, not an affinity group. Anyways, so you can do that from PowerShell, which is awesome. You can restart, reimage, you can change your role instance count. You can now dynamically turn on RDP and diagnostics. So this was a real huge pain point before, if especially for our support people in Windows Azure, is you'd deploy your application. A few weeks later, something would go wrong with it, and you want to RDP into it, and you forgot that whenever you created your deployment, you have to do that at compile time. It's actually a build option in Visual Studio to enable RDP. It's not something you can just go turn on via the portal, or it wasn't until now. So now we've added functionality to dynamically enable RDP and even diagnostics. The only thing that will get you here is you can only turn these on and off dynamically if they haven't ever been enabled in the first place. So the new functionality to turn on RDP and diagnostics is not compatible with the existing functionality to turn on RDP and diagnostics. So what I'm going to show you from PowerShell, if you want the ability to use it, you won't be able to deploy it on cloud services that already have RDP turned on. I know it's confusing, but it's the way. Second thing, you can enable change configuration. We added a new upgrade mode called simultaneous. Has anyone tried simultaneous upgrade mode yet? Okay, so I'll walk through and show you what that is real quick. And we also have a bunch of developer-based commandlets that allow you to scaffold new cloud service apps for Node, PHP, Python, and even .NET now if you want. So let's walk through a little bit of cloud services management. Okay, so the first thing I'm going to show is how to actually do a deployment. How many of you have done a command line cloud services deployment? Anyone? Awesome. Okay, so this is how you can deploy a cloud service without having to go to the portal or from Visual Studio. So I have a cloud service here. I'm going to go ahead and package it up. And you can package this from the command line too using CSPack if you want. But I'm lazy, so I'm just going to use Visual Studio to do this. So it's packaging up my web app, and I need this path to do this. So I'm going to create yet another PowerShell tab, and I'm going to say new Azure service. Hopefully that's not too long. I don't think it is. So I need to create a cloud service first, and then I'm going to create a new deployment inside of that cloud service. It has to be the exact same name, TechEd Cloud Service 1A. And I need to specify the location of the package I just created, and then the location of the configuration file, then the slot to put it in. This could be a production or staging, and then I hit F5. And assuming I didn't forget something, this will take your CS package file and your CS config. It'll upload it to your active storage account that we set earlier, and then it will deploy that out to the cloud. So that's pretty straightforward for an automated deployment. How come you guys don't do this? Is it a lack of awareness or no? So this is how you create a new deployment. So now let's talk about how do you do upgrades? How do you do simultaneous? The reason you want to use simultaneous, well, a couple of caveats. Simultaneous upgrade, the internal name for it is blast upgrade. And why it's called blast is instead of walking the upgrade domains and doing everything in a nice orderly fashion, it just obliterates everything and copies the new files over. So it's really fast, but it also gives you downtime. So you don't want to do simultaneous upgrade on production deployments. It's really only useful for in your staging your dev slot. Unless you don't mind a few minutes of, hey, what was that weird error I saw? So how we can do an upgrade is, let's see, I want to use an existing service so it doesn't take so long. Oops, that's not going to work. So I have an existing service, paths deploy demo 1. Actually, let's pull it up in a browser real quick. So this is our my cloud service. It's a web role, myASP.NET web application deployed with PowerShell. Super fancy. I spent a lot of time building that demo. So what I'm going to do now is I'm going to just completely screw it up and change it around. Updated with PowerShell. So now it's completely different, and hopefully all my customers will be able to recognize it. But now I'm going to go ahead and package this up, just like before. And I will warn you, I demoed this in MMS a few months ago, and for the life of me, I couldn't figure out it would run and it wouldn't update. Thankfully, it was the end of the session, so I just said, get out. No. But I did try it earlier, and it worked like a champ, which means I'm sure it won't work now. So let's go ahead and try this upgrade. So I'm going to say set Azure deployment, upgrade, mode, and this will be simultaneous. Oops. And I need to specify the service name, actually, which is pass deploy demos 1. Same thing, I need the configuration file, which I don't know why it didn't figure it out for me. And I need a configuration. Oops. I don't remember that file name. Yeah. Oh, and of course it wants a slot. So I'm going to go ahead and run this deployment. And instead of walking each upgrade domain, I think this web and work role has 2 roles, so it should at least be in 2 upgrade domains. It's just going to basically delete or take them down and upgrade them at the same time. So it should be faster compared to the standard automatic, which basically does it in 1 upgrade mode at a time. And of course, it does have to upload files, so it's still going to take a few minutes for it to actually work. So while that's working, actually, let's wait for it. So I'm really hoping that it works this time so I can redeem myself from MMS. Question? Right. And you're doing automatic deployment right now? It's going to do the same thing. So TFS is, it basically does CS package and calls those same APIs, so it's not going to buy you a whole lot. A couple of things that you can do to speed up deployments is you can try simultaneous mode, deploy to staging. It should be faster. As you can see, the deployment's already done, hopefully. Before I talk so highly about it, let's see if it actually worked. So in theory, simultaneous will be faster, but you should only use it whenever you're deploying to your staging slot. Once you're deployed to your staging slot, you can do a VIP swap to swap those around. So that should buy you some time. The other thing, it all depends on what your the reason for the delay is. Usually it's just a cause of it has to deploy a bunch of virtual machines and do the upgrade. All right, moment of truth. Maybe. Taking a long time to load again. But another option is, ooh, that's a little too simultaneous. Maybe we're having network problems. Let's see. So another thing it could be, how big is the package size that you're deploying? Yeah, so that's usually the case is because it does have to upload that blob file. One of the things that I've seen customers do is they'll take that package, a lot of that content, if it's not changing a whole lot, and they'll stage it somewhere, like in a closed storage account, and then they have a startup task that actually downloads it at deployment time. So you're not going through the multiple upload process. That's right. Yeah, libraries, there's nothing you can do. Yeah, because those are actually in your bin directory, right? Right. Actually, I think it's even possible to do that. I'm very disturbed that my deployment stopped, though. There it is. Oh, okay. So remember what I said about having downtime? There you have it. This is why you only do that in your staging slot. So we were able to upgrade, but I would certainly look into doing simultaneous on your staging slot and then do a VIP swap after the deployment's complete. And obviously, you're probably going to want to time it, because even after the commandlet says it's complete, it's still going through the upgrade. And I remember that whenever we went through this, is there's no solid way of knowing if whenever everything is up and running, except writing some code to actually go pull the roles. So what you just saw is a lot of PowerShell cloud automation focused on PowerShell. And I hope that everyone was here for virtual machines and cloud services and not, hey, why didn't you automate Windows Azure websites? I'm going to do that later, but right now it's all just focused on compute. So if you guys have any questions, I'll stick around for a few more minutes. And also feel free to ping me on Twitter, or you can hit me up by blog. I'll be happy to answer any questions after. When you actually go try it is usually whenever the questions come. So thank you very much.